Have you ever just looked up at the sky and felt that sense of connection? For thousands and thousands of years, that's what humanity did. We looked to the sun and moon, not just with wonder, but for real answers. So let's get into it. How these celestial bodies became our very first clock, our calendar, and really, the rhythm of our entire lives.
You know, it all starts with a simple moment of curiosity. Picture this. A young girl named Mira is at a kite festival. It's beautiful, the sun is setting, and as she looks up, she sees something that seems a little odd. The moon, just hanging out in the daytime sky. Now, she already knew its shape seemed to change every night, but seeing it up there with the sun, that sparked a question that people have been asking for ages.
So yeah, why does it do that? Why don't we see a big, full, round moon all the time? Is something blocking it? Is it playing hide-and-seek behind a shadow? Or is something else going on entirely? Well, that's the first mystery we're going to solve.
The answer, as it turns out, has nothing to do with the Earth's shadow. Not at all. It's actually something way more elegant, a kind of beautiful cosmic dance between the sun, the Earth, and our moon.
Okay, so here's the key. What we call the phases of the moon, it's just the different shapes of the sunlit part of the moon that we happen to see from our spot here on Earth. The moon itself isn't actually changing its shape one bit. And you can actually try this yourself. It's pretty cool. Imagine you're in a dark room with just one lamp on. Now, hold a ball out at arm's length. As you slowly turn around in a circle, look at the ball. The amount of the lit up side you can see keeps changing, right? It goes from fully lit to a half to just a sliver and then to nothing. In this little experiment, your head is the Earth, the lamp is the sun, and that ball, that's the moon.
And that simple demo perfectly explains the real deal. The sun is always lighting up one half of the moon. But because the moon is orbiting us, our viewing angle from Earth is constantly changing. So when the moon is between us and the sun, we see its dark side. That's a new moon. When we're between the sun and the moon, we see the whole lit-up face, a full moon. And everything in between gives us all those other phases we know and love, the crescents, the half-moons, and the gibbous phases. So let's just hammer this point home, because it's a super common mix-up. The Earth's shadow falling on the moon? That's a totally different event called a lunar eclipse, and it's pretty rare. The phases we see every night are all about our perspective. It's just how much of the sunny side of the moon we can see from here.
Now, this predictable, repeating cycle wasn't just some pretty show in the night sky. For our ancestors, it was something so much more important. It was their clock. It was their guide.
Think about it. Long before anybody had a digital watch or a calendar on the wall, the sky gave us the three big units of time. The sun rising and setting gave us the day. That full cycle of the moon, from one new moon to the next, gave us the month. And the slow, steady cycle of the seasons, all driven by Earth's orbit around the sun, that gave us the year.
But here's where it gets tricky. This led to a huge challenge for early civilizations. It was like a cosmic puzzle they absolutely had to solve, especially if they wanted to get their farming right. So here was the snag. If you count out 12 full cycles of the moon, you don't quite land on a full year of seasons. The two cycles, they just don't sync up perfectly. And the math is pretty simple, but the consequences are huge. A year based on 12 moon cycles is about 354 days. But a year based on the seasons is, as we know, about 365 days. And that leaves you with a gap of about 11 days every single year. So cultures had to make a choice. You could go with a purely lunar calendar, which is awesome for tracking months, but your seasons will start to drift. Eventually, what used to be a winter month would happen in the middle of summer. Or you could go with a solar calendar, like the one most of us use today. It stays locked to the seasons by fudging the length of the months and adding leap days, but you lose that perfect natural connection to the moon's phases. But many cultures, especially in India, came up with this absolutely ingenious hybrid, the lunisolar calendar. It's the best of both worlds. They use the moon for their months, but then, every 2 or 3 years, they just slip in a whole extra month to let the seasons catch back up. It's a brilliant way to keep both the moon and the sun perfectly in sync. And this is where it all gets so much deeper than just counting days. This is where timekeeping becomes culture. This cosmic rhythm isn't just about planting crops, it's woven right into the fabric of how we celebrate and come together as communities. I mean, just look at this incredible Warli painting. It shows a whole community living in total harmony with the cycles of nature, with the sun and moon right there watching over everything. This deep, deep connection between the sky and our daily lives is one of the oldest stories humanity has,
and we've told it through art and music and dance for generations.
And you can still see it so clearly today in some of the world's biggest festivals. Diwali, the Festival of Lights, that's celebrated on the new moon. Holi and Buddha Purnima, they land on the full moon. And Eid al-Fitr begins only after the young crescent moon is sighted. The dates for these huge celebrations are literally written in the stars.
For almost all of human history, the moon was our main companion up there in the night sky. But, well, in the modern era, we've launched a few new friends to keep it company.
Now, these new moons obviously aren't natural. They don't guide our festivals or our ancient calendars. But in just a few decades, wow, have they become essential to modern life in ways our ancestors could have never, ever imagined.
And this comparison says it all, doesn't it? On the left, you've got our natural satellite, the moon, the one that's guided us for millennia. And on the right, an artificial one, a human-made object that we put in orbit, completely changing our relationship with the sky forever. Their whole purpose is different, it's totally practical. Instead of taking a month to go around, they can zip around the entire Earth in about 100 minutes. And in doing so, they power everything from our GPS navigation and our phone calls to weather forecasts and critical scientific research like ISRO's incredible AstroSat space observatory.
And all of this brings us to one final big thought. Our relationship with the sky. It is fundamentally changed. For thousands of years, we looked up to know the time, the month, the season. We looked up to know when we were. Today, we look to our new artificial moons to know exactly where we are on this planet. The sky has always given us answers. The only thing that's really changed are the questions we're asking.